which are designed for them, and special buildings to which they go at night in ones and twos, and occasionally one can see small automobiles, which are obviously the young. And at this point, we would assuredly think we had found the dominant organism. But if we looked closely, we would see that there were small parasites which would come in and out of the automobiles. And we would think that we were now into the microbiology of the organism, disease organisms, and we had made great progress, little imagining that the real dominant organism had yet to be found. We would be quite astonished by a picture such as this, in which there are great organisms, many tens of meters long. Every one of these little white things here is in fact a great whale. And this is a picture taken in the ocean. And then we would see places like this. This is a marvelous sand dune field. And in these great sand dunes, we would see strange creatures like these. And what could these be? Well, we would have the following kind of argument. We would say, look, in this place there are stilted lumps. There's lumps about that size connected to the ground by 4 stilts. And many of them stretching as far as we can see. Now, how do you make stilted lumps? Well, there are no weather ways to make it. There don't seem to be any geology ways to make it. Probably it's a biology way to make it. Not only that, things get rubbed down on the earth. There are sandstorms which rub things down, running water rub things down. And we could calculate that in a period of only a few thousand years, the stilts would all be rubbed away and the lumps should be on the ground. So these stilted lumps have been made in the last few thousand years. There's some machinery on the earth for making stilted lumps at least every few thousand years, maybe much faster. And I think we would have to deduce that that was due to biology, and perhaps these are the dominant organisms. Then we would look closer. Here is a set of interesting creatures which would then be gone about 2 minutes later. This is in fact a flock of flamingos. And if we now look at another picture, here we have for the first time the organisms that we truly know to be the dominant organism, human beings. This is a great outdoor swimming pool. Each dot is a dominant organism. And nearby there are blankets, and on each blanket there are 1 or 2 dominant organisms. But to see what the dominant organisms are really like, we would have to go still closer. And if we really did that, we would finally come to grips with the true nature of the dominant organism on the planet. Now, I'd like to do just for a moment, a stepping back. And let's examine still another picture. We have up to now looked only at the Earth in reflected sunlight. Here's the Earth in emitted light. Up at the top we see, this is North America, up at the top we see a very bright light, which is in fact the aurora borealis. But down here, all these other lights are due to cities at night. Here, for example, is the New York to Washington corridor, and so on. So the Earth, due to its intelligent life, shines at night. Here is a remarkable picture made of the Earth in radio waves. It shows the Earth emitting to space in radio radiation. And look, the map is exactly like in the geography books. And the people who wrote the geography books were never in space. So they did a very good job. And here, this is part of a plaque on a long-lived spacecraft. And here we have the configuration of continents some 200 million years ago when they were all almost together and touching. Due to what is called plate tectonics or continental drift, the continents move apart. Here is their present configuration. And some 8 million years from now, here's what the continents will look like. Britain seems to be still here. Italy seems to be missing. Seem to be a lot of new places in the Indian Ocean. And as I mentioned, over here you can see California having drifted out to sea. That's merely to mention that the configuration of the continents of the Earth is true only for now. At another time, it'll be quite different. Now, to show some familiar geography, you may recognize these small islands. Picture taken from space with quite a configuration quite like that in the geography books. And let us do now another zoom in. In this case, let's try to zoom in on some places that most of you know. Here you can see England in the rough vicinity of London. If we look more closely, we can see the Thames estuary. They have this upside down. And the Thames in the vicinity of London. And then if we look still more closely, we might see some more rectangles, London rectangles in this case, some strange buildings, one particular domed building in central London. And if we then zoom in to this strange building, we can perhaps pick out a random dominant organism in London. There are some dominant organisms now. So we have now done twice a kind of exploration of the Earth and seen, among other things, how varied and interesting it is, but also how difficult it is to look for life. It is not easy to find life. You have to look very closely on a planet to find life that's there. Now, maybe I can have a globe of the Earth. Thank you. All of the things that we've been talking about are on, in the last few minutes, are on the surface of the Earth, and they are conveniently put together in globes like this one. And on this globe, there are national boundaries marked, but on photographs of the Earth from space, there are no national boundaries to be seen, which is perhaps a useful lesson for politicians. The Earth rotates from west to east so that the stars can seem to rise in the east and set in the west, otherwise it would be difficult to explain them. And as it turns in this way, some parts of the Earth plunge into daylight and others plunge into night. And you can imagine, for example, a wave of toothbrushing which circles the Earth once every day at the terminator, the place where light and dark parts of the Earth meet. There are actually two such places, but I'm talking about the morning one. Well, we have so far been talking mostly about the solar system. By now, our Hello Universe signal has passed far beyond the orbit of Mars, far beyond the Sun, which is lovely yellow, as you see. But if that original hello was given, say, half an hour ago, the hello is just now something like reaching Jupiter. How long before it reaches the nearest star? That will take another 4.5 years. The stars are astonishingly further away than the planets. So all we've been talking about is a cluster of little worlds around the sun, and then some immense distance to the nearest star, which may indeed have planets about it. How is this discovered? How is it known how far away the stars are? We cannot bounce radar off the stars. It has to be done by some other method. And let me just give you briefly an idea of how one of the early, very clever minds in astronomy figured out the distance to the stars. This is a man named Christianus Huygens, who lived in Holland, thank you, Bill, in the 17th century. And he argued as follows. He said, "It looks to me as if the stars are suns. The sun is near, that's why it looks so bright. If the sun were some immense distance away, it would be just a little pinpoint of light and seem very dim. How far would I have to move the sun away in order to make it as dim as some bright star at night, let's say Sirius?" So Huygens went out at night and looked at Sirius for a while. Look, look, look. Remember how bright Sirius is. Then, next day, still remembering how bright Sirius was yesterday, he went out and looked at the sun. He had a brass plate, painted black here so it doesn't shine badly to the television cameras. His was shiny. And he held the plate up to the sun and looked through each hole until he could find a hole which was so small that the amount of light from the sun which entered